Have you ever wondered if it's possible to get sick in space? A fascinating question, isn't it? Many of us have this general perception that space is a sterile environment, free from the pathogens that cause illnesses here on Earth. We imagine astronauts floating around in their spacecraft, immune to the sniffles, the flu, or any other ailment that plagues us down here. But is this really the case? Well, it's not as straightforward as it might seem. To understand sickness in space, we need to first understand how our body reacts to this unique environment. Imagine floating in a world where up and down have no meaning. This is the reality for astronauts in space, and it's not as fun as it might sound. The zero-gravity environment of space can have some surprising effects on the human body. Let's start with muscle atrophy. In a world without weight, we don't need to use our muscles to stand, walk, or even lift a cup of coffee. This causes our muscles to weaken and shrink, a condition known as atrophy. And it's not just our arm and leg muscles that are affected. Our heart, a muscle that works tirelessly to pump blood against the pull of gravity, also gets a break in space. But like any muscle, when it's not used, it weakens. Next, let's talk about bone density. On Earth, our bones are constantly remodeling and repairing themselves in response to the stress of gravity. In space, this process slows down, leading to a loss of bone density, similar to osteoporosis here on Earth. This is why astronauts exercise for 2 hours a day in space, to slow down the bone and muscle loss. But perhaps the most disorienting change is fluid redistribution. On Earth, gravity pulls fluids down towards our feet. In space, these fluids spread out, causing a puffy face and skinny legs, a condition affectionately known as chicken legs. But it's not just a cosmetic issue. This fluid shift also puts pressure on the eyes, potentially affecting an astronaut's vision. All these changes can lead to physical discomfort and potential sickness. The body is an adaptable machine, but it takes time to adjust to the new rules of living in space. And even then, the effects of zero gravity can still be a challenge. So, the space environment does have a significant impact on our bodies. But does it make us sick? Let's dive deeper into this question in the next scene. One of the most common ailments astronauts experience is space adaptation syndrome. This condition, also known as SAS, is akin to what we on Earth might call motion sickness. Now imagine being on a roller coaster. You know that feeling of your stomach lurching as you crest the top of a hill and plunge downwards? That's your vestibular system at work. It's responsible for your sense of balance and spatial orientation. On Earth, it works in harmony with gravity to let us know which way is up and down. However, in space, gravity is essentially non-existent. This sudden change throws the vestibular system into chaos, causing a mismatch between what the eyes see and what the body feels. This disconnection can lead to the onset of space adaptation syndrome. Symptoms of SAS are akin to those of seasickness or car sickness, and include nausea, dizziness, and a general sense of disorientation. It's as if your body is constantly trying to right itself, but without a clear sense of up or down, it just can't seem to get its bearings. These symptoms can last for several days as the body adjusts to the new environment. In most cases, astronauts' bodies eventually adapt to the weightlessness, and the symptoms of SAS subside. However, the time it takes to adjust can vary greatly from person to person. The good news is that astronauts are well prepared for this. They undergo rigorous training and medical evaluations to ensure they're physically and mentally prepared for the challenges of space travel, including dealing with SAS. And while it's an uncomfortable experience, it's rarely severe enough to interfere with their mission. But it's also worth noting that SAS is not just an unpleasant inconvenience. It can have serious implications for long-term space travel. If we're to venture further into space, understanding and managing conditions like SAS will be crucial. Space adaptation syndrome is a clear example of how space travel can make us sick, but it's not the only one. And as we'll see in the next section, the challenges to our health in space go beyond just feeling a bit queasy. Scene script. Another factor to consider is how space affects our immune system. Let's dive into this. Research has shown that being in space can have a significant impact on the human immune system. In fact, studies on astronauts have shown that our immune response can be significantly reduced in zero-gravity environments. This is due to multiple reasons, including the stress of being in such a foreign environment, the altered sleep cycles, and the physical toll that space travel can have on the body. So, what does a reduced immune response mean? In simple terms, it means that the body's defense mechanism against diseases is not as effective as it should be. Our immune system is like our personal army, constantly on guard to protect us from harmful invaders like bacteria, viruses, and other pathogens. When this system isn't functioning at full capacity, it can leave us more susceptible to infections. Now, imagine being in space, a place teeming with potential sources of infection. From the recycled air within the spacecraft, to the potential exposure to cosmic radiation, there are numerous ways in which an astronaut could fall ill. And with a weakened immune system, the body might struggle to fight off these infections effectively. One of the potential consequences of this is what's known as reactivation of latent viruses. These are viruses that have been in our bodies lying dormant and not causing any issues. But in space, with reduced immune response, these viruses can potentially become active again, leading to illness. It's also worth noting that a weakened immune system can potentially lead to longer recovery times, so if an astronaut were to fall ill while on a space mission, it could take them longer to recover compared to when they are on Earth. So, not only can the space environment make us feel unwell, it can also make us more vulnerable to illness. This is why it's crucial for space agencies to continue researching and developing ways to keep astronauts healthy during their missions, ensuring that the stars remain within our grasp. So, to answer our initial question, yes, it is possible to get sick in space. As we've explored, the unique environment of space has profound effects on the human body. We've looked at the various ways space can induce sickness, from the disorienting effects of space adaptation syndrome to the more serious concerns of a weakened immune system. The body's response to zero gravity can lead to a host of issues including muscle and bone loss, fluid redistribution, and even changes in vision. The immune system, our body's primary defense against disease, can also be compromised, leaving astronauts more susceptible to illness. But it's not all doom and gloom. Scientists are hard at work studying these effects and developing ways to counteract them. They're looking into everything from specialized exercise routines, to combat muscle and bone loss, to advanced medical treatments that could help bolster the immune system in space. Indeed, the challenges of space travel are many, but so too are the opportunities for discovery and advancement. Every problem encountered, every sickness studied, brings us one step closer to understanding how to live and thrive in space. And who knows, the solutions we find may not just help astronauts but also provide insights into treating diseases and improving health right here on Earth. While space travel presents many challenges to our health, our understanding continues to grow, helping us prepare for a future where more of us may have the chance to venture beyond our home planet. As we continue to reach for the stars, it's important to understand the risks involved. Indeed, the journey to the stars is not just one of technological prowess or strategic planning but of human endurance and adaptability. The vast expanse of space with its harsh environment and zero gravity presents unique challenges to our bodies and health. Space exploration is an endeavor that pushes the limits of human knowledge and capabilities. It's a testament to our curiosity, our innovation, and our relentless pursuit of understanding. But as we venture further, we must also delve deeper into understanding the impacts of space travel on our health. It's a fascinating, complex, and crucial field of research that combines elements of biology, medicine, and space science. We've discussed today how the human body can react in space, how it can potentially get sick, and how our immune systems respond in such an alien environment. But there's still so much more to learn. Space adaptation syndrome, for example, is just one of the many health issues that astronauts may face. Understanding these conditions and finding ways to prevent or treat them is not only crucial for ensuring the safety of our astronauts, but also for making long-term space travel a reality. So let's continue to be curious. Let's continue to ask questions and seek answers. Let's continue to learn about the universe and our place within it. As we do so, we also learn more about ourselves, about our bodies, and about our incredible capacity to adapt and survive. I encourage you all to continue learning about space and human health. Whether it's through reading articles, watching videos, or even pursuing a career in this field, every bit of knowledge we gain brings us one step closer to our dreams of exploring the stars. Remember, every step we take into the unknown helps us better understand ourselves and our place in the universe. As we gaze up at the night sky, let's not just marvel at the beauty of the cosmos, but also appreciate the wonder and complexity of the human body that allows us to embark on such extraordinary journeys.